CAD and 3D Printing Milestones course. My name is Andrew Baum, and I will be your course instructor for the next 5 weeks. Unfortunately, the recording for the first session was corrupted, so I'm going back and going through all of it for anyone who may have missed class or who wants to go back and reference it. So a little bit about me. I'm a junior in mechanical engineering here at Purdue University. I recently moved to San Jose, California, and I actually have around 6 or 7 years of CAD experience. I'm also quite a 3D printing enthusiast, which you'll start to see in the next few weeks. One fun fact about me is that I'm a barista that doesn't drink coffee. Here are some of my CAD projects that I've done over the years. I did a lot of robotics in high school, so you'll see that I did make some robots here on the right side, and then here on the left is my SCAR robot arm that I've been working on. We also have two lovely TAs for this course. One of them is Frederick, who is a sophomore in ME. He's from Indianapolis. He's been CADing for about 2 years now, and he's been doing a lot of stuff in uh, in gear, and he helps around the LinkedIn page, and he is also left-handed. We also have Avantika, who is also a sophomore in ME, and she's also from San Jose, California. She also has 2 years of CAD experience, and a fun fact about her is that her favorite season is fall. So typically, we have students download Fusion 360 at this point. Because this is a recording, you can go about doing that now. There's a couple of ways you can do it. I have provided installers via a Google Drive link right here in the Discord. So if you go under resources, you can go into this installer page where you can download the client for either Mac or Windows, depending on your machine. If this doesn't work for you for whatever reason, then you'll have to set up your Autodesk account and download it from their website. Typically, I have people download it off of here because it saves a little bit of time because you can download it while you're making your account. So, what is Fusion 360? Obviously, you're taking a CAD class, so it involves some kind of CAD software. So the CAD software of choice in this course is Fusion 360. So a majority of your assignments will be conducted using this program. We like using it because it's free for students here at Purdue, and we also find it pretty intuitive and user-friendly, especially for people who are just learning how to CAD. Another advantage to Fusion 360 over some other softwares is that there is a cloud-based option. So it really helps a lot with file sharing and collaboration. I know that I've used this program in a couple of my classes and different clubs just because it's easy to set up group projects when you're designing things. So a little bit more about this class and milestones in general. So you're taking a milestones course, and some of you may be wondering what that is. It's basically a series of skills-based workshops. So it's kind of an enrichment course that adds on to whatever you're taking during the semester. So it supplements coursework, and instead of getting a grade for it, you just have a pass-fail system. So upon completion of this course, you will receive a digital certificate from Purdue, and you can put that on your resume or your LinkedIn to show people that you know what you're doing. Keep in mind that these certificates sometimes have a lengthy process to authenticate them and stuff like that. So if you were to complete this course, this fall, it still might take a couple of months for you to receive your certificate. So don't freak out if you don't get it right away, because they will come eventually. Some course objectives for this class. This is pretty high level stuff, but we want you to understand the importance of CAD because you're going to be using it a lot, and it's a good idea to know why you're using something. On top of that, want you to gain the necessary tools or learn the necessary tools to create a model or just anything that your brain can think of on the computer. And then in the end, we're going to hope that you can render um, your model and then also learn how to 3D print them so you can get a physical representation of your work. Um, I did not mention this during the week one lecture, but you will have the opportunity to 3D print your final projects. So in the end, you'll send your file to me and I'll print it out for you to have like a little thing to take with you um, for completing this course. Uh, as some of you may know, this class is being run by students of ASME. So I am a ASME member here at Purdue, along with um, my other two TAs. So our goal here at ASME is to prepare members for success in industry. So whether that's gaining leadership experience, um, you know, preparing your resume and other things like that, ASME is a great place to learn and grow with the students around you. We have plenty of professional development opportunities and a bunch of design teams that you can work with to enhance your skills. Some of the design teams are over here, like small projects. In previous semesters, they built drones. I remember a couple semesters ago, they built BattleBots, which is what brought me into ASME, and I loved my time there. But there's a bunch of other design teams for any interest that you may have. So, of course, small projects like I was just talking about is really fun. But we also have sports equipment, sustainability, Rube Goldberg, prosthetics, hydroponics, Grand Prix, and a bunch of others that aren't even listed here. One of notable one is the rover team, where they're competing in a national rover competition. So there's a bunch of things that are design teams that you could join for any interest that you may have. And the great thing is that you don't have to be a mechanical engineer to join ASME. So ASME stands for the American Society of Mechanical Engineering, but we are open to any major. So I have friends in material science and business joining these design teams to input their, uh, you know, their skills and specialities into our projects. So just because you may not be a mechanical engineer does not mean that you can't join this wonderful group of people. So yeah, like I mentioned before, we have a bunch of professional development things as well. So if you need help building your resume and stuff like that, we do that too. And if you're interested in learning more, you can join our Slack to be informed for future events. So here's a QR code. You can try and scan it if you're interested. If it doesn't work for whatever reason, feel free to message me on Discord or something. I'd be happy to forward you our Slack information or anything else that you might be interested in. But yeah, that's ASME for you. Going back to the course a little bit, this is the first lecture out of 5 modules. So today we're going to be doing kind of an intro to some CAD stuff. Remember, this is a beginner-friendly course, so we're going to take you from the beginning all the way to more advanced design practices. So we meet every Tuesday from 5:30 to 7:30. Today is September 3rd, and then we'll be going all the way to October 1st for this session. And at the end of this session, we will have a final, but I'll talk about that in a little bit. This slide just kind of gives you a little breakdown of how each week is separated and their point values. These are all the assignments that you're going to be asked to complete throughout this course. And just remember that we have a passing requirement of 70%. So you have to, average a 70% on all these assignments to pass and receive your certificate. But don't worry too much because I will be doing a lot of these in class. So a lot of these assignments are demos. So if you show up to class and you follow along, you should be well on your way to passing. Um, for me, I always tell students that the main reason why people don't pass this course is because they stop showing up. Because again, I do a majority of the assignments in class, and whatever that I don't cover in class, the homework assignments, for example, are all topics that um, are covered in class, and the homework assignment is just to help you build on your skills more independently. So as you'll see in a little bit, I'm going to be teaching you basic shapes, like making a simple hammer and a game piece, and you'll be able to use what you learned today to do your homework to make a chair. So we're going to dive into that shortly, but yeah. Again, like I said earlier, there is a final for this class. So we're going to have you design your own part from scratch and render it. So though this may seem a little bit uh, intimidating to beginners, I assure you that this final really isn't that bad. Um, it just requires that it's not something that we've made in class, like the engineering fountain, for example. We're going to be doing that in a later week. And then it just has to contain at least 5 design features. You may not understand what that is, but don't worry, we will cover that later. And you'll soon see that 5 design features really isn't that hard. For some of our other assignments, you're going to be covering 5 design features, no problem. So the final project shouldn't be too big of a deal. It's just there to let your imagination fly and show us what you got out of this course, and also show yourself. So yeah, here are a couple photos of past finals from our students from other sessions. As you can see, some people put a lot of time into their final projects, which is totally awesome to see, because again, you really get in this course what you put in, right? So if you put in a lot of work, you're going to learn a lot. But if you want to do the bare minimum, if you have a really large course load from your other classes, that's perfectly fine too. So this course is meant to be flexible, so you can challenge yourself as much as you want. So if you haven't done this already, you're going to need to make an Autodesk account to access Fusion 360. So when you do this, I'll say this multiple times, but make sure you use your Purdue email, because your Purdue email will tell Autodesk that you're a student, and it'll really help you get your education license a lot more easily. So if you go back to the Discord, you'll see there's a registration link under resources. You can click that to register. It'll ask you to put in your information. Again, use your Purdue email, please. It'll really help you quite a bit. And then you'll run through the process to create your Autodesk account. For some people, they'll ask for a little bit more information, like Purdue's address and website. The address is down here in resources again, 610 Purdue Mall, West Lafayette, Indiana, 47907. And Purdue's website should just be purdue.edu, pretty sure. Um, If you're ever having trouble with that, I can show you real quick. Um, Sign in real quick. Okay, so once you're signed in and you make your account, you can go under products and services, and it'll show you uh, what programs are available to you. Because I have my license already, you can see I have access to Fusion 360 here, along with the host of other Autodesk softwares. If you're having any trouble at all, I like to reference this over here in the bottom right corner, where it'll pop up like an AI chatbot. So normally what you would go through is just clicking education and trial support, and then software for students, teachers, and schools. And then I click show examples. Um, for some, you might need to renew your education access. So you can say that here, or verification of my student account. You can click, or you can type in either of these, and it'll kind of just run you through the process. Um, might send you to some more links, um, and following these should help you gain access to your education license. Again, if you have any trouble at all, feel free to reach out to me or the TAs. We're happy to help you. Um, but yeah, um, now that you hopefully have Fusion 360, this section forward will just be going straight into the demos. So let's start with the basics. Basically, we're starting from the beginning. So what is CAD? So CAD stands for Computer Aided Design. Basically, you're just using a computer to design something virtually, right? You can design individual components, like one piece at a time, or you can combine them all to make something like an assembly. So CAD is a very powerful tool that we're very lucky to use, because back in the day, people just were using pen and paper. Uh, People just sat in big rooms just full of people designing parts for companies and other stuff like that. But now we have the ability to do that with one person with a laptop. And in some cases, those laptops don't even have to be powerful these days because of cloud computing. Little brief history of CAD. It was invented by this very smart dude at MIT in 1959. As you can see, some of the early CAD machines were very large, room-sized computers doing those calculations. But over time, CAD programs got more advanced and computers got even more powerful, to the point where I'm teaching it to you on a laptop today. Obviously, there's a bunch of different applications for CAD programs. Um, you know, Almost everything that you see and use on a day-to-day basis has likely been CADed at some point, unless it's some handmade, piece of art, something like your computer, or your monitor, or the car that you drive, the bicycle that you ride to class. All of those things have likely been designed on a computer with some CAD software at some point. Um, there's 2D CAD, 3D CAD, you know, simulations. CAD is just a very powerful tool, especially with the simulations, which we offer as another course in the milestones. You can take FEA, which is finite element analysis, and it'll allow you to take a part that you designed from a class like this, and it'll allow you to simulate stresses and stuff like that. So CAD is a very powerful tool that can do so many things. Obviously, Fusion is not the only CAD software that exists out there. It is a part of a family of CAD programs that Autodesk has. Its big brother, Inventor, is used all across industry, but there's a bunch of competitors that exist for different reasons, like SolidWorks and NX, some of which you may have experience taking classes here at Purdue or elsewhere. But they all essentially aim to do the same thing, which is to aid you in designing a part on the computer, right? The UIs might be different, but at the end of the day, they all do very similar things. We just prefer Fusion just because of its flexibility um, and ease of use for students. With all that out of the way, I'm just going to jump straight into um, our first assignment. So we're going to create some building blocks. And before we do that, I'm going to kind of show you a little bit of the Fusion 360 layout. So I've already launched Fusion and finished the class, but I'll start from scratch over here. So when you first boot up Fusion, it'll probably ask you to log in with your credentials that you just made with your Autodesk account. Make sure you fill in that information. It'll probably ask you to make a team if it's your first time using Fusion 360. Naming your team is just, or it'll ask you to create a team or join an existing team, sorry. Creating a team will basically allow you to store all your files. So you can name it whatever you like. It'll just kind of be named like your Google Drive or something like that. So creating your own team will create your own personal workspace for you to store your files. But if you were to join a group, that's something that you could do later. Over here on the top left of this toolbar, um, there's this kind of square of squares. Clicking on it will show and hide the data panel. So the data panel is kind of where you store all your files for easy organization. For me, I organize these projects for this class by the session. Over here on the top left, you can see all the groups or the teams that I'm a part of. So some of them are from, projects that I did in class. Some of them are part of ASME, and some of them are part of other organizations or my personal one. So here, I just have a team that's just dedicated to this course. So that's what I'm in right now. In those teams, you can create projects. So here, for each session, I will have a project. For this, we're in session 1, fall 2024. And this is where I'm going to be storing all the stuff for this class. So I'm going to hide the data panel by clicking the square of squares, and it'll give us a better view of our main workspace. So here, down here in the center that's taking up the most space is your main workspace. This is where you're going to be making sketches, extruding, and designing your part. On the top here with the toolbar is all the functions that you may need to create your part. You'll see that sometimes it will change depending on what you're doing, but for the majority of this course, we're going to be staying under the solid area. So there's a bunch of different settings that you could choose, and it'll change the layout, um, but want to make sure that we're in solid. A good way to know is that most of the solid icons are blue, so if yours ever looks orange for whatever reason, you're probably in surface. So make sure you're making a solid. Other than that, to move around in your workspace, there's a couple shortcuts that you can learn. So the main one is zooming in and out by scrolling on a scroll wheel or something like that. You can pan back and forth by holding middle click, and it'll let you go side to side. And then if you hold shift and middle click, you should be able to orbit. And orbit is just rotating about your part. In this case, I'm kind of rotating around the origin because I don't have a part yet. So that's why I really recommend a mouse. So if you don't have a mouse, I highly recommend you get one for this class because you really want something that can middle click. If you don't, that's okay. It just might be a little bit more annoying to navigate your workspace. There's a couple alternatives, one of them being the view cube on the top right. If you hold down and move the view cube, it'll let you orbit, and you can still zoom in and out if you don't have a scroll wheel. Another more uncommon way that people like to CAD, for me, I like to do this when I'm out and about, is having a touch screen. So if you have a touch screen on your computer, it actually is not too bad if you don't have a mouse and you want to CAD something and you're out and about. But yeah, that's just kind of how you can move around your workspace. With that said, I'm just going to start making parts. So the first thing that you want to do most of the time when you're making a part is making a sketch. So typically we make 2D sketches, and then we use those 2D sketches to create 3D objects. So the easiest way to make one is just going up here in the top left and hitting create sketch right here. And here's a good example of why we like Fusion, or why we like to teach Fusion to beginners. Because if you hover over a certain tool, it will kind of expand out and tell you what the tool does. So here, telling me what the sketch does, and you can do it for all of these too. So I'm going to create a sketch. You can see I have a couple options here. These kind of yellowish orange rectangles are the planes that you can select. So because we're creating a 2D sketch in a 3D environment, you have to specify the plane. For me, I'm just going to choose this plane, and it's going to kind of fly into place. So you can see that I chose the top plane, because over here on the view cube, it'll tell you that you're viewing things from the top. So for this assignment, we're making a cube, a cylinder, and this kind of bridge looking piece. So I'm going to start simple and make a cube. So over here, you can see the toolbar has changed with sketch tools. So now I can use the sketch tools to create the geometry I'm after. So I'm going to select 2-point rectangle because I'm making a square, and I'm going to start at the origin. So when you're first designing things, especially when you're designing a new part, it's a really good idea to start your sketch from the origin. And the reason why I stress this is because the origin is the only defined point in space when you're first starting your design. So you want to use that so you can fully define your piece. And you'll start to see what I mean as I continue. So the origin is right where my mouse is. I'm going to click, drag it out. And now we have a rectangle. You'll notice that two of the lines on the rectangle are black and two of the lines are blue. And that is because these two lines are defined and these two are undefined. And what I mean by that, like I was saying, because these are on the origin, um, they are constrained in a way where you can't move it in certain directions. So this vertical line right here can't be moved side to side no matter how much I try to drag it. It's because it's constrained to the origin. Same with this horizontal line, I can't move it up or down. But because this horizontal and this horizontal line aren't constrained by anything, I can drag them, make them bigger or smaller. So to fix that, I'm going to add some more constraints. So over here, there's the sketch dimension constraint. What you can do is you can click what you want to dimension. You can move your mouse up. It'll pull out this kind of drop down for a measurement. If you click again, you can specify that measurement. I'm going to go with 50. And now you see uh, this vertical line change from blue to black. And it's because I can't move it side to side and I can't move it up and down because of this. So we're going to give this the same treatment. I'm going to set it to 50. And now this horizontal line is fully constrained. So it's a good rule of thumb to keep your sketches fully constrained. So you can see on all four sides of this cube or of this square, each line is black. So it's fully defined, and you can see if I try to like stretch or move this in any way, it doesn't work. The other thing to note is the inside is highlighted as a bluish color, and that means this area is a closed loop. So there's no gap in between any of these vertices here. It's just one big continuous loop with no breaks, which is what we want in this scenario. So we're going to create a cube out of this square. So I'm satisfied with this square. I'm going to click Finish Sketch in the top right. You can see it's just limited to this plane. But to make it 3D, I'm going to use the Extrude tool. So right next to the Sketch tool, there's the Extrude tool. Here, it'll allow me to select the profile, which it auto-selected as this square. If I was to close it, you can see this becomes blank, but I can click it and it'll be specified. Start is where the extrusion starts in relation to the sketch. So if you were to make a sketch on, let's say, the wrong plane, and you wanted the circle to, or you wanted the cube to start from a different spot, you can use offset. Or if you want it to start from a certain object, you can start it from here. So there's a bunch of options. I'm going to use profile plane here. For direction, you can see there's many different options here as well. Two sides basically allows you to specify how much in both directions you want it to be extruded, and symmetric is equal on both sides. For my case today, I'm just going to use one side. Extent type, I'm going to set to distance because I'm setting this manually. But if you wanted it to go all the way up to an object, you can do that, or you can make it even go through your entire part. where in this case, I don't really have a part to go through yet. So these are kind of not useful in this scenario. So I'm going to select distance. For distance, I'm going to set it to the same width length as the dimensions on the square, which was 50. And you can see now that I've created a 3D part. I'm not messing with taper angle because I just want it to be square. And then operation is set to new body. You'll see that Fusion sometimes will assume that you want to do something, but you don't want to. So here is the operation is pretty important for what piece that you're making. So in this case, making a new body, but you'll see that we're going to use join and cut as well. So here we have this nice cube. If you've been following along, now we're going to create a cylinder. So make a cylinder. I'm going to create a sketch like I did before. And I'm going to just show you that you don't need to just choose the planes from the origin. I'm just going to use this face as the place to start my sketch. So I'm going to be making a cylinder. In this case, I'm kind of being a hypocrite and not drawing my part on the origin, but it's just because for this demo, we're creating like 3 parts in one drawing, but typically we kind of separate them all and draw them from their own origin. So I've created the circle, and here's a great example of why you start on the origin. If I set this diameter to 60, the diameter of this circle won't be able to change, but it's not fully constrained, and that is because I can still move the entire circle around. So to fix that, I'm going to add a sketch dimension. I'm going to click on the center of the circle and the center of the origin, and I'm going to start adding dimensions. And you'll see that I prefer kind of having like an X and Y approach. So this is the Y and the 100 is the X. You can technically use this diagonal measurement, but typically I find it to be good practice just to use X and Y coordinates. So with this X and Y coordinate set for the center of the circle, you can see the circle is fully defined in this scenario, which is good. I'm happy with this, so I'm going to finish my sketch. I'm going to extrude it to make it 3D. Now that there's more faces and stuff like that, it's going to ask me to specify the profile. So right here, I'm going to select this cylinder right here. Under Start, I'm just going to set it to offset just to kind of show you how it works. I'm going to set the offset to like 30. And you'll see that the bottom of the arrow, which was on the circle, has now been pushed out. For direction, I'm going to make it symmetric just because I can. And for the distance, I'm going to set it to 60. And you can see from here, this blue area is where I drew the sketch, but because of the offset to here, it doesn't start extruding symmetrically until here. So keep in mind how symmetric works. It can be useful depending on your scenario. So I'm happy with this cylinder, so I'm going to press OK. Now we have our second part. Again, these two are just kind of floating in space. This is technically not what we would want you to do, but for demo purposes, this is okay. You're just getting the fundamentals and understanding how they work. Cube, we're going to start making the last piece for assignment 1, which is this arched block piece. So there's many ways you could go about doing this, right? And the cool thing about CAD is there's no technically wrong way of doing it. In my opinion, there are more efficient ways of doing it, but it doesn't mean that the way that you choose to do it is wrong. For me, what I like to do, depending on the part, is I like to use the face. I like to start with the base that is most complex, because it might allow me to kind of combine operations to make the features or timeline a little bit more organized. So if you didn't know, on the bottom of Fusion is your timeline. So it'll kind of walk you through all of the operations that you've done for your model. In this in this example, we still only have like a couple features here on the timeline, but as you start making more and more complex parts, these timelines can grow really, really long. And it's just kind of good practice to consolidate and combine to make it a little bit easier for yourself and maybe even other people who may open your file, right? Your timeline is kind of like a book or like a story of how you made a part. And if your timeline is all jumbled, it'll just make it harder to read and edit if need be. So with that in mind, the two ways I can think of making this off the top of my head is you could create this rectangular prism and then cut out this arch, or we can just create the whole arch without having to add another operation to cut it out. So let's do that. Again, I'm making a sketch. I'm going to choose this plane this time. And I'm going to start sketching. So here, I'm going to create another rectangle. I'm going to go a little faster this time. Maybe set this to 200 and 100. You can see it's not fully defined because I'm kind of straying from the origin. So I'm going to add the X and Y coordinates here. This is fully defined. I'm happy with that. And now I'm going to create the arch. So I'm going to be drawing a circle. You can kind of see here that Fusion will kind of snap to important segments or parts on lines and circles. In this case, it is the midpoint of this horizontal line, and it's shown by having this triangle right next to your cursor. So you'll see no triangle, but then once I get here, I have a triangle. I want this circle to be centered, so I'm going to be drawing it here. I'm going to drag it out, add dimension, say like 150, and you see it's fully defined. But there are a couple extra lines now. So the cool thing about CAD is that you can just trim them away with something called the trim tool. So you can click up here or press T for the shortcut, and it'll allow you to cut away unwanted lines. So in this case, I don't really want this bottom part of the circle, so I'm going to click it, delete it. And I also don't want this horizontal line stretching across the whole part. So I'll delete it again, or I'll trim it away again. But you can see when I did that, the circle, which is now an arc, has become blue. And that's because I deleted the reference geometry that the circle was referencing, because it was on the midpoint of the line, which doesn't exist anymore. So to fix that, there's a couple things we could do. You could do it manually by subtracting this 150 from this 200, and then dividing that by 2 to get the two lengths of this arch, or you can make the computer do it for you. So this is a little bit more advanced, which we'll be talking about more next week, but we're going to be using a couple of geometric constraints today. So over here is the sketch dimension tool, which is a dimensional constraint, but all these red functions over here are geometric. So yeah, you can see how since we trimmed it, this circle can move side to side, arc, and it's because these lines aren't equal to each other. So if I wanted them to be equal, I can, not press that. I can press the equal sign and then click the two lines that I want to be the same. And you see when I do that, the arch becomes centered and everything is happy. I'm going to finish the sketch again, extrude it just like before. And we're good to go. So here are all the models for this assignment. Again, you just want to make sure that you have all the parts here. In this case, this looks good to me, but you also want to add appearances depending on the rubric. So for this, I do want them to be colored, so I'm going to add appearances. There's a couple ways you can go about doing that. I like just pressing A, and then the appearance like kind of wizard will pop up, and it's right here. But you can also access it by going down here in the top left, right-clicking a body if it wants to right-click as appearance, or I believe you can even right-click the part for appearance. So now that we have the wizard open, you can click on Fusion Appearances, and you will notice that there's such a wide range of variety in terms of material types and color. For me, I just use simple paint colors, but you can use whatever you like. Though I will say, if you use a gray or a black or a really dark colored, there's a chance that I might think that you didn't add an appearance at all. So I would highly recommend you choose a bright color instead of like a gray or a black. So in this case, I'm just going to be using blue and a couple other colors. So you can find the appearance that you want. Sometimes you might have to download it with this arrow here. I've already downloaded a couple colors, so I'm ready to go. But once you've downloaded it, you can just drag and drop to your part, and you should be good to go. So yeah, that's assignment 1. Again, if you're following along and you took a screenshot of your work right now, you should get full points. So that's why I highly recommend you come to class. For homework submissions, you will submit all your homework assignments on Google Forms, and you'll submit them all at the same time. So how homework works in this class is they'll be assigned 1 week or on one day, and then you'll have an entire week to finish those assignments. So the 3 demos and homework assignment for this week will be due before next week's class time. Um, so please turn it in by then. When you go about submitting the Google form, all you have to do is take screenshots of your screen in Fusion 360. I would highly recommend you include the timeline, or at least get into the habit of doing it, because in later weeks, the timeline will become important enough that I will take points for it not being there. Because I want to make sure that you're doing it in the way that I'm hoping you are. So anyways, again, just screenshot and submit it with all the rest of them on the Google form. So that's assignment 1 finished. Let's move on to assignment 2. So assignment 2 is the Purdue hammer. Again, there's a couple ways you could go about doing it. Just by looking at this part, you can see how there's a cylinder, a hammer, and then another cylinder on top of it, right? So you could make a cylinder and then make a hammer on top, or the hammer head on top, and then that nub on top. But you can also combine these two, which I'll show you in a second. To create a new design, you just click here on the top right, just like any web browser, and then you can start making your part. So again, I'm making a sketch. I'm selecting the top plane again, circle on the origin, adding a dimension, and there we go, fully defined. If that was a little fast, feel free to rewind, but I'm just going to move on. So we have our finished sketch. We're going to extrude it just like we did for the blocks. Maybe something like 500 might look nice. Also keep in mind for like the document units and stuff like that, for most of the assignments, it's not something I really care about too much. So you don't need to copy the numbers that I'm doing exactly. As long as you're getting the gist of what I'm doing, you can make really funny looking pieces, game pieces, at least I've seen. So you'll have the creativity to do that, or the ability to do that. So I set this to 500 millimeters, the new body, yada, yada, yada. I have this handle. So now I'm going to create the head. So I'm going to create another sketch. And again, you can create sketches on already existing geometry. And I'm going to create a center rectangle. So over here, if I click create and I go into rectangle, there's the center rectangle tool. And just because of how this part is being made, I really want to make a center rectangle. So I'm going to click on the origin. Oops, that wasn't the origin. Let's close that. I'm going to click on the origin and drag it out. And you can see this rectangle is centered by the origin. I'm going to add some more dimensional constraints. And I'm pretty happy with this. So I'm going to finish the sketch. You can see how it's sitting on top, but we're going to extrude it in a different way. So I'm going to click the extrude button. I'm going to select my profile, or ask me to. And then for start, instead of profile plane, I'm going to set it to offset. So you can see how the arrow moved again. It moved in the wrong direction. So if it ever is doing that, you can just change the sign. So in my case, I'm setting it to -20. And then for distance, you can see the arrow is still pointing the wrong way. So I'll set it to negative 40, or maybe more. Negative 60. How about that? So you can see that there is an offset, which should be 20 millimeters from the top of the cylinder to the top of the head. But the head is red, and that means it's being used for the cut function. So over here, there's the operation that's set to cut, and I'm going to change it to join because I want these two to be one solid piece together. Yeah, that looks good to me. You can see how with just two features, if I press OK, with just two features, I was able to create this, which could have been 3 or more. So a good thing to keep in mind. I think the last thing to do on this assignment is to add fillets to all the corners. The fillet tool is right here, and it allows you to create a nice curved and smooth surface for your holes. It looks nice and it feels nice. So I clicked on the fillet tool, I selected all the faces that I wanted to have fillets on, and now I can specify the size. You can see as I increase the size for the fillet, the more round it gets. So depending on what you're after, something like this might be up your alley. So I'm happy with that. I'm going to press OK. And there is our assignment 2. Again, screenshot it and submit it once you turn everything else in at the same time. Please try to avoid multiple responses because I grade all the responses, and if you upload something like 5 times, I'm going to be recording it or I'm going to be grading it all 5 times, and it'll get kind of tedious, especially because I'm only giving you 1 score. So just wait till you finished everything and upload everything once it's done. Thank you in advance. Oops. So the last piece or the last assignment that I'm going to demo today is this game piece. So instead of extruding, we're going to be revolving this time. So revolving works very similarly to the disc and washer method that you may have learned in calculus if you took it. So basically we can create a quarter, almost like a quarter of the game piece that we're looking for, and then it'll spin about that axis until it becomes a fully solid body. So to do that, I'm going to make a new design up here, just like a web browser. I'm going to start with a sketch again. So I'm going to try to replicate something like this. In this case, I want it to sit up on its side, so I'm drawing it from the front, and you can start sketching. So I'm going to go out horizontally, vertically, here. Circle here. Line here. And arc. So the arc, I typically use the 3-point arc, but other uses have its own purposes. That allows me to dial in the skis. these two lines, or these two endpoints here, and you can see it's starting to take shape, but we can make some improvements. So to make this transition really smooth, you can highlight both of them and select tangent. When I do that, it'll find a line that kind of continues this straight. The other thing I'm going to add is this vertical line right here to fully close this, and then I'm going to start trimming. So trim. You can see here, this is a closed body, which is what we want. I'm not going to bother adding and fully constraining this just for teaching purposes, but you definitely can go back and change all of these numbers however you like. So instead of extruding, you're revolving this time. Because this is the only part in here it auto selects. But you need to specify the axis of revolution. So right here, I want it to rotate about this line, because if I was to do it here, that doesn't really look like a game piece. So I'll do it here and press OK, because I set the extent type to full because I want it to go all the 180 degrees. I mean 360, can't count. But yeah, this looks good to me. And press OK. Now we have our game piece. The last two parts of the puzzle is adding appearance to this. So add appearances. Sometimes it hides, you have to expand it. I'll make this game piece red. All right, so now that it's colored, the last thing we want to do is adding text at the bottom. So to do that, I'm going to create a sketch. I'm going to select the bottom face game piece, and then I'm going to go under create and text. And you'll see you have a lot of choice when it comes to the different geometries you can make in the sketch, but in this case, I'm just using the text command. The cool thing about the text command is you can have it like fit in a box, but you can also have it follow a path. I'm just going to leave it as simple, following this box. And then inside the box, you can write whatever text you like. I'm just going to say hi. And then you have full control over the size, the font, and even flipping it, backwards or vertically, upside down, all that fun stuff. I'm just going to press OK because I like that. I press Finish Sketch. And then I'm going to extrude the high into the pawn or the game piece. So here you can see Fusion tried to guess what I was doing, but in this case it wasn't correct. It selected the whole bottom profile, but I don't want that, so I'm going to click this X. I'm going to zoom in, click this lettering, and then we're going to start to cut it out. You can see the direction is going the wrong way, so I'm going to set it to negative, and then let's say I want it to go in by like 3 millimeters, right? Changed it to -3. If you look at it, you look closely, it's cut into the part, so that's what we want. The operation is set to cut because I'm cutting it out. I just press OK. But yeah, that is an overview and demo of the first three assignments. The homework for this week is to create a chair. Um, these requirements are pretty lenient and loose. Your chair doesn't have to look exactly like this one, so feel free to let your imagination run wild. So you'll see you're going to want a chair with at least 4 legs, a seat cushion, and a backing. Um, a couple ways you could go about doing it is by, extruding these legs up from a sketch that's maybe rectangular or something like that, creating another extrusion for the bottom of the chair, um, stuff like that. So you can see that what we learned today should be applicable to the homework. Make sure you use fillets for this. Adding fillets will make your chair less sharp, look maybe a little bit more organic. But other than that, you have free reign to make whatever you like. That is the end of this week. Good luck. Again, feel free to reach out if you have any questions. We're here for you on the Discord. Um, if you're ever curious for the course material, the slides that I just ran through are posted here. The rubric and specifically what I'm looking for in each assignment is here. So if you're unsure of how I'm going to grade something, you can go off this rubric. This Google form here is the assignment submission. And then down here are the attendance forms. So I didn't talk about the attendance policy for this class, but basically how it works is there are no unexcused absences allowed. So the reason why I have that is that I want to know where you are if you're going to be missing class. Because if you tell me, I'm hoping that you're more likely to come back and watch the recording afterwards. Because if you don't say anything, I won't know if you're just ditching the class or um, you are genuinely busy. And this class is always at capacity, so there's always someone who's looking to get off the wait list. So if you continuously don't fill out the attendance form, I'll probably drop you from this class and bring someone else in. So I don't want to do that. So please, please, please fill out the attendance forms when you attend class. Or if you're not going to be there, please message me and then fill out the absence form. But other than that, thank you for tuning in to week 1, and I'll see you next week.